Okay, let us look at this question, a very standard and simple question. This is also MSQ. So, let us take this MSQ from operating system. Which of the following standard C library functions given are library functions will always, look at this, the keyword is always, associate a system call when executed from a single threaded process in a Unix or operating system environment. So, always and in Unix. So, sleep is basically to allow the process to get blocked. Blocking the process is never in the hands of the user, right. So, we have to take the support of operating system. So, therefore, this will always generate a system call. Malloc. See, malloc is basically for dynamic memory allocation. We have the characteristic in the literature of Unix and Linux that whenever malloc requires a large chunk of memory, system call is always generated. But when it requires small chunks of memory, then what happens is it will not generate system call for every memory allocation, but rather for the first time, even the memory allocation needed is less, for the first time it will allocate a large chunk so that it can keep it, and later for subsequent calls of malloc to avoid the wastage of overhead of system call, it will not make or activate system call, but rather from the large chunk that it got allocated, it will allocate memory for the subsequent mallocs. So, that is what is happened. So, therefore, this is not correct. Always is incorrect. First time yes, sometime yes, but not always. String length is a normal user level defined function, therefore, this also will not generate a system call. Exit for for terminating the program has to be done through operating system support. So, this will also generate a system call, will be associated with a system call. So, therefore, the correct answer is sleep and exit, sleep and exit. Okay. Now, look at this code from semaphores. S is a semaphore initialized to 5, counting semaphore initialized to 5, S is initialized to 5 in line number 2 here, and counter is a shared variable initialized to 0, counter is initialized to 0, please observe. Assume that the increment operation in line 7 is not atomic, means preemptive, preemption can happen. Okay. So, in the entry section we are performing 2 wait operations, and then in the exit option we are performing section we are performing 2 signal operations. Okay. So, right, remember this is counting semaphore initialized to 5, every wait will not get blocked, okay, every wait may not get blocked, 5 times I can perform wait operation successfully. So, what happens now, if 5 threads execute, there are 5 threads, 5 processes execute the function parop concurrently, which of the following behavior is or are correct? MSQ. The moment I say is or are, MSQ. There is a deadlock involving all the threads. So many times we have seen in our lectures the deadlock may happen with this, we demonstrated, again I am demonstrating, please follow. If I start with P1 execute wait on S, success, value become 4, preempt, start P2 value become 3, preempt. So, if I allow every process to execute the first statement, all of them, right. So, now the value of S become 5 because all 5 processes have executed that. Then when I start the 6th process wait on, now it will perform wait on a second block, second process block. So, all processes can get blocked, deadlock can very well happen, we have proved that so many times in the classes. So, therefore, deadlock is possible. The value of counter is 5 after all the threads successfully complete the execution of parop. If I execute counter plus plus without any preemption, individually one by each thread, individually one by each thread, then counter first thread will be made 1 by first, then 2 by second, 3 by third thread, 4 by fourth thread, 5th by 5th thread. So, sequentially without preemption, if I execute this code, very well the counter can be 5. So, therefore, very well this answer is also correct. Got it? Now, third, the value of counter is 1 after all the threads successfully complete. Is it possible? Yes, with preemption that is possible. So many times we discuss in the class. How? Preemptive execution. Remember, counter incrementation is actually counter is equal to counter plus 1 will require instructions like load, add, store. So, one thread if it get preempted before store and after that you complete all the threads and allow the first thread to execute store, it will store 1, from 0 it will store 1, as simple as that. The final value can also be 1, this is also correct, this is also correct. The value of counter is 0. 0 can never be possible. We have seen that so much. That is the fundamental point. So, 0 is never possible. So, therefore, the correct answer is ABC. Alright. The correct answer for this problem is ABC of MSQ. Good. Now, look at this direct problem. The 3 processes arrive at time 0 with burst times of 16, 20 and 10. So, 3 processes. I will write process number, arrival time, burst time 1, 2, 3, 0, 0, 0, 16, 20, 10, 16, 20, 10. Okay. Minimum average waiting time. Minimum average waiting time is possible with SJF, non-preemptive. He is also saying non-preemptive. Is how much? NAT question. Very straightforward. Prepare the Gantt chart using SJF. CPU. So, first P3, 10, then P1, 26, then P2, 46. That is it. Find the waiting times. Come on. Waiting time of P1 is 10. What is waiting time of P2? P2, so 26. What is waiting time of P3? From the Gantt chart, 0. So, 36 total waiting time. It is asking average waiting time. So, 36 divided by 3, 12. That is it. Straight away. Okay. In the context of operating system, which of the following statement is or are correct with respect to paging? MSQ, is or are. Page size has no impact on internal fragmentation. No, page size will have internal fragmentation. With paging, page size, last page may have internal fragmentation. No is false. Paging helps solve the issue of external fragmentation. Primarily, that is objective of paging. Paging overcomes the problem of external fragmentation. Paging has been designed to overcome the problem of external fragmentation. Paging incurs memory overheads in the form of page table. Very true. Multi-level paging is necessary to support pages of different size. In a vague statement, that is incorrect. So, therefore, the correct options are B and C. B and C are the correct options for this. Okay.